All right, welcome to lecture. We'll get started here in just a second. Continuing on chapter 14, talking about titrations. So again, I think we should be at this slide. All right, so let us get started here. So just to remind where we sort of left off last time, we left off last time talking about, excuse me, a titration here. And again, it's a specific titration we were talking about last time, which is a titration of a strong acid and a strong base. So in this situation, much like the picture in the top right there kind of shows, we have sodium hydroxide or the strong base up in the burette. And in the flask or the beaker, we have our strong acid. So the example that we looked at was hydrochloric acid, and we would be adding the strong base to the strong acid in this case and doing our titration. And again, this is our titration curve. That is why when we start the titration, before we've added any strong base in this particular case, like we talked about last time, pretty much all we have in the beaker is a strong acid. So if we wanted to calculate the pH of that solution, again, before we began this particular titration, all we would have is a strong acid, which means it would 100% break apart, which means essentially at that point, if it's a monoprotic acid, you have the H plus concentration, and you pretty much can go directly into the pH equation using the original concentration. Again, here we haven't added any base or any volume, so the molarity will be the same. So you could go right in with the molarity at that point. Once we do start to add some base, which is this sort of point here, all the way up until before the equivalence point, we will see sort of a rise in the pH a little bit as we continue to add our base to it. And as we talked about at that point, you do get the reaction between HCl and sodium hydroxide. And it does require you to do at least one ice table. This ice table has to be done in moles because we're adding volume, so the molarity will continuously change. And we want to do this, basically the point of the ice table is to figure out how much of your strong acid will still be there after you add your sodium hydroxide. Again, because at this point, before the equivalence point, you could sort of think of the HCl in this case as sort of the excess reagent, and the sodium hydroxide sort of as the limiting reagent. So when we add that sodium hydroxide in this particular example all the way up until the equivalence point, it will pretty much get used up as it's sort of limiting in that aspect. So requires one ice table done in moles. After that ice table is done, you can convert the moles back to molarity by using the total volume, which in titration terms would be the volume of the acid you started with and how much base you added to it. You would then convert it back to molarity, and at that point you would have again the molarity of your strong acid, and you could go into the pH equation at that point again with the concentration, which is what you need when you go into the pH equation. Now, once we do reach the equivalence point, remember that is basically the definition there of the equivalence point. That means that the moles of the acid should exactly equal the moles of the base. And what that means is technically you don't have to do an ice table at this point, because what that will mean in this particular titration is if we did an ice table, the moles of the HCl would equal the moles of the sodium hydroxide, which means they both will cancel out to 0 at that point, at the equivalence point. And really the only thing that would be left at the equivalence point in this type of titration is really a salt. And that salt would have came from a strong acid and a strong base. So as we know about salts, that means that that's going to be relatively weak. It is not going to go through hydrolysis or anything like that. And that means that essentially the pH should always be 7 in this type of titration when you reach the equivalence point. And again, that doesn't necessarily mean just this combination of strong acid, strong base, but pretty much any combination of a strong acid and strong base. Once you reach that equivalence point, pretty much the only thing that you should have left is a neutral salt, and the pH should be 7. So you really don't have to do much of a calculation in this type of titration at the equivalence point. Pretty much just need to put pH of 7 on the paper, and that's the reason why. Now, if we go past the equivalence point, which is this jump past it in this sort of green circle here, we pretty much have now switched around what's happening. So before the equivalence point, our HCl was the excess reagent and our sodium hydroxide was the limiting reagent. Once we sort of move past the equivalence point, there is a switch that occurs, and our sodium hydroxide now is pretty much the excess reagent because we just keep adding and adding and adding. And our hydrochloric acid will be used up at that equivalence point. And what that means is you do have to do an ice table past the equivalence point. Again, that ice table does need to be done in moles. And again, the purpose of this ice table is to figure out how much strong base you have left over, not acid, because it's all gone at this point. So it's to figure out how many moles of the strong base you have left over. You then can convert it after that ice table into molarity. And that will allow you to go again into the POH because it's not the H plus concentration, it's the OH minus concentration. And then you can subtract 14 to get to your pH. The other thing that we also talked about is, as you can see on most of these titration curves, it does go extremely vertical as you get to the equivalence point. So typically, much like this curve here, there's usually like a jump in pH to the equivalence point, and then you typically will see another jump in pH past the equivalence point. And because it goes vertical as you approach the equivalence point, that explains again what you often hear when people do titrations, that I only added 1 drop and the color went from colorless to like super dark pink and all that kind of stuff. And that's because as you near the equivalence point, it does not take a lot of volume of sodium hydroxide in this example to change the pH a lot. And just that 1 drop is enough sometimes to jump the pH. And as we talked a little bit about last time, indicators basically work over a pH range. So again, just by adding that small little bit of sodium hydroxide, it would be enough to change the pH a lot in that solution very quickly. And that's why you typically, for example, with phenolphthalein, can see it go from almost colorless to like this kind of darker pink color with a matter of like a drop or maybe 2 drops or something like that. Any questions on this type of titration here? Okay, so again, a reminder, if you do have questions, feel free to ask them. Even if we moved on, we'll go back and answer that. So I think we went through this with sort of made up numbers and stuff. So the next type of titration that we're going to talk about, again, is a different type of titration than the previous one that we just talked about. We're going to talk about a titration of a weak acid with a strong base. So the setup is pretty similar as to the last one. We're going to have our crooked burette. Should really get that fixed, perhaps. Try that again. See if we can do better. All right, take 2. There we go. A little bit straighter. So we have our burette, and again, it's going to be, in this case, sodium hydroxide up here. And on the bottom, we will have our weak acid that will be there. And we are adding, again, our strong base to our weak acid. And this is going to yield us a titration curve that looks very similar to the last one. So again, we're starting down here. And we got this typical kind of S curve that's occurring. And we also see, just like before, as we approach the equivalence point, we got this kind of vertical line that's going up. And then it will kind of level out as we get to the top of the curve. And let's talk about sort of what's happening in this particular titration. So before we add any sodium hydroxide to it, and the only thing that we have basically in the beaker is a weak acid. So if we wanted to figure out the pH at the start of the titration, all we have in this example is the acetic acid. And because it's a weak acid, it is going to break apart into H plus and acetate. And that means if we wanted the pH here, we would have to do pretty much an ice table and a regular Ka problem. We would do an ice table. We could do this ice table here in molarity again, because we have not added any sodium hydroxide or anything like this. This ice table here would be our molarity. This would be 0. This would be 0. We would use X's here, which means at equilibrium, we would have the molarity minus X, X, and X. We would go into our Ka. We basically would solve for X. And X would equal the H plus concentration. And then that would get us to the pH at that point. So already you could kind of see that this type of titration is a little bit different in terms of the calculations that needs to occur than the previous one. Here, because in the previous one we were starting with a strong acid, we pretty much could go right into the pH equation. But different here, we're starting with a weak acid, which means it is going to require an ice table. You could use the initial molarity to do so. You're going to do your X's. And again, when you solve for X, that is going to give you your H plus concentration. And then at that point, you can go into the pH equation. Any questions on that? So let's take a look what happens in this type of titration once we start the titration. So as we start the titration, we see a gradual rise here in the pH because we're adding sodium hydroxide all the way up until before the equivalence point in this particular case. We are going to actually start to get this reaction to occur as we're adding. So we're going to get the acetic acid with our sodium hydroxide. And let's see really what is going to happen there. So let's get a fresh piece of paper-ish and sort of see. So this is really before the equivalence point. And you're going to have that reaction of the acetic acid plus the sodium hydroxide. Going to give you your sodium acetate. Plus your water. I'll get that in there, right? There we go. All right. Fix that real quick. Pen is not happy today. Try that again. All right. So again here, just to show you what a table would look like at this point. Yeah, I'll go back in just a second. We'll go back to look at it actually. So to show you sort of what's happening at this point of the titration, here we are again starting with our acetic acid in the beaker. We're adding our sodium hydroxide. So I'm just going to make up the numbers like I did last time. So this I'm just going to say is going to be 4 moles. And again, we do want to do this table in moles because we are adding volume. Now, because we're before the equivalence point, what we are adding, which in this case is sodium hydroxide, should be less than what we started with. So again, just making up the number, we're going to go with 2 moles. And this guy is going to be 0 at this point. Now, because we're at before the equivalence point, the change is always going to be the smaller number, would be the sodium hydroxide, which is the limiting reagent at this point. That would give us plus 2 moles coming this way. That means that when we do get to equilibrium here, that's going to give us 4 moles. Not bad math. Should get a calculator maybe. Let's try that again. 2 plus 2 is 3. Let's try that again. Here we go. 4 minus 2 should be 2, I think. Got the calculator. There we go. This guy should be 0, and this guy should be 2 moles at this point. Any questions on sort of how that ice table looks at this point? Just like any sort of titration ice table that you do, once you're sort of completed it in moles after this first one, we would want to use the total volume here and convert it back to molarity. Again, the total volume would be how much acetic acid we started with in this and how much sodium hydroxide we added in this case. And again, if you're not 100% sure sort of what's going on at this point in the titration, your ice table is very helpful for you to figure it out. If you look back, what we have there is our acetic acid is left over. We also have a little bit of sodium acetate left over. And hopefully, if you look at those two things, the acetic acid and the sodium acetate, those two things are related to each other. That is essentially a weak acid and its conjugate base. And that is better known as our good friend, a buffer. Yeah. So what you're left with in a titration like this, anywhere from when you begin the titration, you start adding the base to right before the equivalence point, is you will end up with an ice table that looks just like this. And what you will always be left with is basically a buffer at the end of that, which does give you 2 options like a normal buffer. Probably the best option would be to go into your Henderson-Hasselbalch equation. And that will give you the pH of the solution at that point. Or like we did when we're talking about buffers, you could do a ice table. So you could do a second ice table where the initial concentrations would come from the equilibrium concentrations from the first table. The important thing is, just like we talked about when we did buffers, is if you go and choose to do the second ice table for something like this, you would probably set it up with the acetic acid. You should have a number. Henderson-Hasselbalch is you need to have the number of for our acetate as well. Yeah, are you guys all having sort of choppy video audio? I'm getting sort of a lag in terms of my writing as well. So I tell you what I'm going to do. Let me. I'm going to stop this meeting for a second, and I'm just going to kind of reload everything, and we'll start it back up in a minute or two just to see if that sort of fixes it. As I'm writing, I get in a lot of sort of lag behind it as well. Again, sometimes they've been having some trouble with everybody being on obviously at once and stuff like that. So I tell you what I'll do right now. I'm going to stop the meeting. Give me about 2 minutes, and then I will restart in about 2 minutes. Okay. So we'll pick up from here. So just give me a couple minutes to kind of restart it, come through the same obviously link as you did previously. Okay. And we'll see if that maybe will fix it.